Hello, my name is Zayed, student number 0383567. I'm My role was the deployment part, and I'm grateful for the team and the designer for making a good job in this project, contributing equally and delivering the final result, the product that I will showcase a very important part of it today, which is sustainability trends and how we can extract this data from our database with query joining three tables to get the estimate score, and based on collection of entries we have, we can see the average and compare, and then we can make decisions on which has a better sustainability score to make better decisions or to make decisions. So if we see here, we have if you see here, we have route name, which basically is the routes, destinations, and we have transportation types, three, electric, petrol, and hybrid, which is mix of both, and average estimated score. So for route names, we have cities, shopping mall, residential cities like from city to city. It's a long distance sometimes, and shopping mall can be from like a drop or a stop to a shopping mall, or from shopping mall to a shopping mall. And residential can be inside the resident area, or from resident area to another also. But city to city is further. That's the most further distance. But still, we can see the average estimated score for electric transportation types are 4.8. That's pretty high. Here we're joining these three tables and group by descending from average sustainability score, and we can see clearly electric wins. So hybrid, which is not fully petrol, uh, electric and petrol, it is also has a good score. It's 4, almost 4, 2.9, almost 4, but it's pretty good score. 2.5, however, is not a good score. That's a low score, and it shows that petrol, it gets the job done and it has its use case, but it's not the greenest way. And this is the result from average of entries. And um, this is pretty good way to present and show how to extract data from our tables, joining three tables, getting these rows, and seeing and making decisions, which is more sustainable. So we can choose and make bookings and analysis and reduce like CO2 if we want to try to reduce our CO2 emissions, or we have goals. So we can plan and have plan. And yeah, so this is the result, and this is the query that joins these tables, and we're using aliases and making this as a result for a human readable better way to read instead of ID and stuff. But yeah, um, thank you. I'm really glad that the outcome and the product showcases this. This is important, and the entries we have had a great result. I can clearly see which routes and transportation type, and from average sustainability score, which one to make a decision if I want to go green. So, yeah, thank you. My name is Zayed, and that's the sustainability trend and sustainability score. Thank you.
Hi, my name is Christopher Lee, and I will be talking about the AI model accuracy during monsoon season. The objective of this is to assess the frequency of artificial intelligence models during the monsoon season and the consistency of their performance. Here, you can see the code that we used for this and the result. As shown here, in between these two dates, we will show the AI models that has been used, the version of it, how many times it has been used in between these months, and the total records outside of this month as well. Now, what is the insight of this? Is to identify the AI models with the highest usage frequency during extreme weather, and the performance reliability can be corrected under pressure conditions. The objective is to assess the customer behavior towards optional additional services and the impact of dynamic pricing of their choices. Lastly, this allows help to the pricing and marketing teams determine whether dynamic pricing strategies promote or hinder customer participation in additional products. Thank you.
My name is Shautam Bigo. Today I'm going to discuss about the pricing range and demanding price flag. The thing is that many customers, many foreign are actually booking add-on and booking thing. To demand to show them the pricing choice, to show the kind of pricing choice. The thing is the pricing choice of add-on use and price and calculate the price range and demand. When customer arrive to see a discount price, it will help to boost up the strategies, tourist strategies and everything with strategies to have marketing strategies and also to promote the customer purchase additional product. Promote a customer purchase additional product to show their prices range and high. When the foreigner visit arrive at a hotel, visit hotel, visit the price to show the marketing strategies and everything. Thank you.
Hello, my name is Shangtian Yi. Today, I will briefly introduce the analysis of booking frequency in the tourism route area with a focus on understanding the brief travel areas of trust through the usage of additional service. As shown in the figure, we used an SQL query statement to analyze the frequency and price of tutorials use of additional service under different pricing stages. The focus of the query is to compare the differences between dynamic pricing and non-dynamic pricing. The results show that under dynamic pricing, trusses used additional service a total of 12 times with an average price of 24.5 per use. In the case of non-dynamic pricing, the total usage was only 8 times, and average additional price was also relatively low, at only 13.75. The analyzed result indexed an important problem. The dynamic pricing stages are more capable of stimulating tourists willing just to come through additional service. This might be because dynamic pricing can better reflect market supply and dynamic, making the service more activated.
Hello, my name is Zhu Hao. Let's look at state assessments for bookings. Our data show a problem. Some bookings have no state segment, whereas there have too many. For example, one booking had zero state but another hide the tree. This is not efficiency. Here how we can improve this situation. First, we'll implement real-time state tracking to ensure every booking gets proper coverage. Next, we'll use AI-powered shadowing to automatically brand workloads across our staff members. Uh, Last is focus on busy areas first. Their changes will help our transport system run smoother in 2025.
Is He Ming. The conclusion is my part. The conclude our presentation. Our growth project KL City moves in forward thinking AI-powered smart transportation database platform. Designed for the KL in 2025, the system supports real-time booking, multimodal and transport options, stability tracking, and dynamic pricing use AI model. We built a well-structured database with realistic data. Each table has more than the 20 rows. Show how it would work in the real life. What makes KL City move special is its flexibility is ready for future technology like 6G network, edge computing, blockchain for travel points, and support for many languages. We also create helpful reports using SQL. There is reports help people make smarter decisions about money. Staff performance, eco-friendly rules, and customer habits. As Schultz KL moves is more than just a database, it's a smart city tool made for future growth. The better efficiency and green urban life.